Hello, so in this video we're going to look at, in particular, develop an exam technique and around how we can, one common strategy in exam questions is to think about how part A will help you do part B, which helps you do part C, and so on. This particular question about integration, you really need part A to help you do part B, and in particular it's about, if you're stuck with a part B, how can I, explicitly thinking about how I can use part A to help me to get through this question. So this question says to use integration by parts, okay, to find its integral. Now we're going to need the integration by parts formula, so you get that out of your formula booklet. So I'll put it out here for reference. So it's the integral of u by dx which uv minus the integral v du by dx. So that's the formula that we're given. Okay, and I think about what our u's and v's are going to be in this case. Now, the sort of our choice of u is determined by this rule. You might have late, so you might have YH, that's what the rule, depending on how you've been taught. So L for logs, I for inverse, so inverse trig functions, A for algebra, T for trig, E for exponentials. So we want to think about how we're going to use those to decide what it is. So this always tells us what u is going to be. So u is going to be, we're going to start off with logs. We've got log 3x, so that's going to be u. That means the other part is dv by dx, which is going to be 1 over x squared, because that's what we're multiplying it by. So we need to differentiate the log one. So differentiating that, so I'd get, thinking about differentiate to 1 over whatever's in the bracket, and then you times what's in the bracket, and it's just the same as 1 over x, because you can actually just split up the log as log 3 plus log x, and log 3 will differentiate to 0. Okay, integrating this one, so I've differentiated that one, and now I need to integrate this one. Okay, it might help to think of this as x to the power minus 2, add 1 to the power, x to the minus 1, divide by a new power, I'm going to get a minus. This is minus 1 over x. And now we can apply our integration by parts formula. So I'm going to write that in full. So log of 3x over x squared is going to equal uv. So u times v is this bit. So I've got minus log 3x over x. I need to minus the integral of v du by dx. So these two things together. Balancing things together, I've got minus 1 over x squared dx. This is the same as minus log 3x over x. Now I've got two minuses, so that's plus integral of 1 over x squared. And that we've actually just done here in this step. So our final answer is minus log 3x over x minus 1 over x. Not quite. What do we need to remember? We always need to remember plus c when we've got an indefinite integral. So that's part A, that's 4 marks, standard integration by parts question. We now need to see what we've got here for part B. So we've got a volume of revolution question, because we're talking about the volume of a solid when it's been rotated 2 pi radians about the x-axis. So when I'm thinking about something being rotated about the x-axis, we know that our formula is pi integral between the values of something dx. That's going to be y squared dx that we're integrating. Okay, so we need to now got our formula for y. Okay, we've got our limits from a third to 1. So we can now think about just how we're going to put everything into this formula. So it's going to be pi integral from a third up to 1. And it's y squared, so that means I need to square from the back. So I've got log 3x. I'm going to square all of that. Notice the 2 doesn't come down to the front. That only happens when the thing inside the log is squared, not when the log itself is squared. I'm going to divide that by x squared dx. Now this log 3x is a bit ridiculous to write, and we're not used to using these. But let's think about how this relates to part A. I've got the same denominator, got x squared, then if I look at the top I've got log 3x squared, here I've got log 3x. So I'm going to rewrite this integral so that it looks like the one before it. And the other way I can do that, I've got log 3x times log 3x over x squared. And now I'm just going to say, let's do that, x squared. So I've got, this first bit is my actual, what I've just integrated in part A. Right, that is the same as this bit here. So that tells me what my choice for dv should be, the thing that I need to integrate, because part A just told me how to integrate it. So my choice for u would be log 3x. That means du by dx with 1 over x as before. My choice for dv by dx, weirdly enough, is going to be that other part, log 3x over x squared. And then I can work out v, but that's what I did in part A. So that's minus log 3x over x minus 1 over x. Now, as standard of integration by parts, you don't need to put the plus c in the v term, because you'll just make it a bit more complicated and it'll just come out as a constant in the end anyway. So let's start what our volume is going to be. So it's going to be pi. Now don't forget that pi's there, it's quite easy in a question like this where you've got lots of integration, but just forget that pi's there, it's always there. Okay, so uv, that's going to be, so uv is going to be those things times together. I'm using square brackets because I'm going to evaluate that bit. So minus log 3x squared, because I'm timesing them together, over x, minus log 3x over x, so times those two terms out. That's going to be evaluated between a third and 1, minus, got another integral to do. Okay, that's this one, v times du by dx. So what do I have to do that? I've got minus log 3x over x squared minus 1 over x squared dx. Brackets, some more one term in the integral, then brackets around the whole thing and time it all by pi. Now let's get rid of these minuses in this, but you should have already noticed again something similar to the previous part. I'm just going to copy this down so you want to skip past this bit. Make clear, so it's a bit better to do that with brackets, just make it clear. So that's going to be plus the integral from a third to 1 log 3x over x squared plus 1 over x squared x. Now what should strike you again is that this thing is the same thing that's circled above and before it. That's another integral that we are given, right? So we know we can do with that because we've just realised how to integrate it. And then the 1 over x squared part, that's something that's relatively easy to integrate. So carrying on, so I've got my volume is equal to pi times, well, we can now probably put the whole thing in brackets, in our square brackets. So I've got minus log 3x squared over x minus log 3x over x. Now if I were to integrate that thing, it's that. So I'm going to get minus log 3x over x, another term, minus 1 over x. and to integrate 1 over x squared, we did that earlier, that becomes minus 1 over x. We get another one of those. Then we're evaluating that between 1 and a third. Let's put the value for 1 in. Say, don't forget that pi there. Get minus log 3 squared, 1 minus log 1, right, log 3 over 1 minus log 3 over 1, you could simplify 4, minus 1, minus 1. And we're going to minus from that and put a third in. Now, log of 3 times a third is the same as log 1, which is 0, so all the log 3x terms are going to disappear. You have minus 1 over a third, minus 1 over a third, like that. As we're getting there, we've got a volume, pi times minus log 3 squared, minus 2 log 3, minus and 2, plus, and I'll get 3 from that, I get 3 from that, 3 minus 3, sorry, I get minus 3 from that, minus 3 over minus 6, when I'm taking it away, I get a plus 6, so the volume is going to be pi, lots of 6 take away 2 is 4, minus 2 log 3, minus log 3 squared, like that, and that's in the exact form, so you don't put it as a decimal, because in a question you wanted the exact value of the volume, not an approximate value. Okay, so reflecting on that question, the key parts there were that we, first of all, could do part A correctly, that we could integrate by parts, but then secondly, that we could use that in the next question. It's a real application question, because you're really having to use part A and think about how you can apply that to help you to do everything in part B, and it comes up more than once as well. But when you do that, you're not actually having to do that much thinking, you're just having to see how you can use part A while you do part B, so that's a really important exam technique. If you're stuck with a question, it's always worth considering looking to the previous part to see if it might help you move forward with the part that you're currently working on.